Hey everyone, welcome back. Hope things are going well at home. Wanted to continue on in our series and see if we can't knock out a few more of these videos. I hope these are helping people at home while you're sort of stuck trying to figure these out. But if you do have any questions, don't forget you can always give me a call, or as you may have noticed, I'll be calling you. So today I wanted to look at misleading statistics. Now, this topic seems particularly relevant today because I don't know about any of you, but as I've watched some of this news at home, can't help but think like this is not, they're not always being honest about the numbers, which is really scary in something like this because the numbers really matter. So let's look at a couple of these things. So let's talk about misleading statistics in a sort of general sense. And there goes my coworkers. Hi, everyone. Okay, so let's look at this one, and I'll read this to you guys. Misleading statistics. So here's an example, fundraising. Because the track team is going to regionals, they need to raise some money for the bus and the hotel. The boys team has decided to work on selling chocolate bars. They figure that this will be an excellent choice for a bunch of students. Easy to sell and not expensive, says as he sells candy bars at lunchtime. This is not true. Parents hate these because they end up buying all the damn chocolate. Don't do these things. Anyway, at the end of the fundraiser, the team began to tally up their totals. Mark sold 72 bars and Clint sold 65 bars. Mark wants to make it look like he has sold more than Clint. How is this possible? How can he do it? So, did he? Well, yeah, he sold more than Clint. He wants it to look a little bit more, though. So, we're going to show how he's able to use this to lead other people astray by using some misleading statistics. In this lesson, we'll talk about the following skills: identifying and analyzing misleading data displays, identifying and explaining misleading comparisons of data, design data displays to intentionally exaggerate or minimize comparisons, and revise data displays to eliminate misleading representations or conclusions. All right, so what does it mean? What does it mean to mislead? Well, we do this all the time, right? Everybody shades the truth a little when you're telling something. So this is how you can do that with data. And it actually turns out statistics are great for this. It's one of the reasons politicians use them. So when we've built graphs and plots, we've taken care to show the data correctly by choosing appropriate intervals and scales. The intervals, remember, are like how big of a group do I look at? For example, with the coronavirus right now, one of the things they're saying is that people from 20 to age 44 are at a particular risk level. That's a pretty big age group. Some of you guys are almost 20. Well, I'm not even 44 yet. I don't know that you and I have the same sort of health issues at this point. So that's what they mean by intervals. And by scales, we say, well, what if I stretch it so that one, instead of being this far apart, is this far apart? And now it looks like a really big difference. So at times we simply make mistakes, but other times people are doing this intentionally. So let's look at this one. This is the Eula high school graduation rate. And they're looking at percentage. So they're using a bar graph. So why? Because they are visual devices that allow us to compare the size of two different things. Since we're comparing two different years, we don't need them to actually match up. I have to remember this is backwards for me. So what do they show? Well, it appears that here the graduation rate is significantly higher, right, than here. But wait a second. If you look at this scale, this is 83 and this is 87. And when we're talking about percents, 3% is not necessarily a huge change. So what they did was they stretched the scale to make it look like there's instead of a small difference of 4%, a huge difference. All right. So for another example, a sales manager at Bank X prepared a report of the number of new clients they have in the quarter compared to their competitors. He prepared a graph and declared that although they had fewer new clients, they're not far behind. What do you think? Is he being honest? Is he not being honest? Scroll down. Well, what do you think? Well, if we look at this here, it looks pretty similar, right? They're not that far apart. If I were just glancing at this quickly, I might say they're pretty close. But when we look, wait, Bank Y has 46% more new clients and Bank Z has 59 more percent. Does that look like that much of a difference? No. Well, how come? Look at this again. The scale here jumps up by 200. We have a lot of space at the top of this scale. Can you imagine if instead we went from, say, 0 to 600? That would show a significant difference between these. An appropriate scale would have gone to 600. Yeah. So once again, we have to look at how the graph is constructed to see if the data is misleading or not. So step 2, identify and explain misleading comparisons of data. We could also look at what it means when we have data that compares. In the last example, we compared different banks with new accounts. We can also look at comparison within other arenas. Let's look for misleading representations. For example, a hospital director was up for his evaluation. He wanted to show that he had helped the community in his years on the job. He prepared this graph for the evaluation committee to show how well his work has helped to reduce cases of the flu. Does this feel a little bit relevant? I honestly, God did not read these enough to know ahead of time how relevant these would seem. True or false? Did flu cases decrease? What do you think? Well, yeah, they did. Yeah? Are they way down? No. So what did he do? He changed the scale, but also the size of the bar. The scale is actually maybe appropriate. I might have squished this data in here. If you use a broken line and you sort of zigzag it back and forth, you can start wherever you need to. So he could have actually showed a bigger difference that way by breaking the scale at first. But the other thing he did was, if you notice, this bar is significantly wider than this bar, which gives a visual representation that it's a bigger group. He was actually able to show that in a way that wasn't accurate just by manipulating the size of the bars. Some graphing programs actually won't let you do this because it's really seen as a dishonest thing. So the 1990s bar is very wide, which gives it the appearance of being much bigger. And then this one is much narrower. It's a 12% decrease. Frankly, a 12% decrease right now seems pretty good to us, doesn't it? It's amazing how much this is changing the way we're seeing the world. You can see, even if the comparison looks like it's true, we have to examine the actual data to see if the data display is accurate or misleading. By the way, this is one of those things I see all the time with studies. They'll say something like, girls are as abusive to boys as boys are to girls. Okay, but when you look at the study, that's not what it actually said. They grabbed a little tiny piece and they blew the whole thing up. So there are some newspapers that are particularly known for doing this, but you really actually have to look at the studies themselves. Anytime you see something that says a study claimed, you should go look at the study. Next part 3, design data displays to intentionally exaggerate or minimize possible comparisons. Why am I teaching you to do this? Well, it's actually really handy if you're trying to make a point. Say you're a salesperson and you're really wanting to sell something because you believe it is the best product, and if you don't, go find someplace else to work, or because this is what you've got. Anyway, as you can see, it is important to keep an eye on the data and the way that it is presented to us. In order to improve your skills in spotting misleading data, let's see how you can design data displays to intentionally exaggerate or minimize comparisons. Here's an example. Mei Ling knows that her grade point average has dropped but doesn't want her parents to notice. It went from 3.75 to 3.25 in one semester. How can she manipulate a graph to mislead them? She decides to change the width of the bars to make the lower score look bigger. So here she has one that's narrow and one that's much wider. Another thing she might have done is make the scale a little bit bigger. Although that's harder with something like grade point average because most parents who care about the grades are going to know that it's out of a 4. So there are things she could have done, but this was probably a good choice for this one. Of course, it's not as tall, but do you think her parents will notice? Last part is revising data displays to eliminate. So now that you know how to look for them, let's see if we can't fix some that we can catch. Here we go. Four team members on the swim team recorded the following data for the 400-meter relay. Notice that we have David, Manuel, Andre, and Luke. Which one's the fastest? David. Which one's the slowest? Manuel. Pretty big difference, right? David actually made a graph of the data, and here's what he showed. So what do you think? Is this a reasonable? They all told Manuel he needs to work harder because he's bringing the team down. He has been working hard but didn't believe the graph. He noticed the scale was designed to show a major difference between their times. He made the graph the second way. Hey, look, all of a sudden these don't look so different. So we're looking at two different graphs of the same data. Now, I might have also suggested to him that one thing he might look at is, hey, wait, how come we put me here instead of either, at the end? So we could have seen, well, so-and-so's the best, and then the next, and then the next. So we have David, Luke, Andre, and Manuel, because the difference here is not as great as the difference here. So there are two different ways they've sort of manipulated this data. On the other hand, in something like sport, some teams will talk about like the 1% difference. If we can do everything 1% better than everybody else or than we did before, we'll improve. It's a really big thing in cycling to talk about. Okay. Real life example completed. So all the way back at the beginning. So fundraising. So we're going to look at how we could show who is selling the most chocolates. So it's easy to sell and not expensive. At the end, Mark sold 72 bars and Clint sold 65. He wants to make it look like he sold a lot more. Is this possible? How would we do this? Well, create a bar graph and skip numbers in the scale. In an appropriate graph, a scale may reach 75 or 80 beginning from 0. However, if Mark skips 0 through 60 on his scales, the bars look really different. So here's one way he did it, right? He actually did this, but he didn't do the little zigzag, which is legit and a little shady at the same time. So in this, it looks like Mark sold a lot more than Clint, but 7 bars is not that much of a difference in something like this. He's really manipulated this data to make it. So, last but not least, time to practice. So I want you guys to try all of these. I realize there's a lot of them, but this is really important. And these are pretty quick. These are true false. To sell more of a product, a company may create a display that misleads customers. 2, you can create a graph to make it look like you have sold more of a product than you actually have. 3, misleading statistics aren't that relevant in sales. 4, graphs aren't actually misleading at all. 5, you can create a misleading graph only if your intervals are too small. 6, you can create a misleading graph whenever your intervals are too small or too big. 7, the height of the bars in a bar graph can be misleading. 8, if the bars of a graph are too wide, this can be misleading too. 9, you must be careful whenever you read a data display. Uh-oh, sorry. There we go. You must be careful when you read a data display to be sure the data is accurate. Okay, now the ones that actually require you to think a little bit more. Why are the following graphs misleading? What is the error in the conclusions drawn based on the graphs? 10. Conclusion. The population in Dagwood is exploding. Doesn't it look like it is? Conclusion. George's Cafe is far more successful than Rita's restaurant. Here's the 2 here. Draw a graph to intentionally exaggerate this data. From 2002 to 2004, the average number of semesters that students studied in order to complete their bachelor's degree increased from 4.1 to 4.5. 13. Explain the faulty conclusion that could be drawn from this graph. 14. Draw a graph to intentionally minimize this data. Mike had 110 customers on his paper route in March, and in June only 75. 15. Explain the faulty conclusion that could be drawn from this graph. 16. Revise your graph in number 3 to represent the data more accurately. And 17. Revise your graph in number 5 to represent the data more accurately. I'm not looking for works of art here. Please don't bother to put these in a computer and make them perfect. Sketch something really fast. I know you guys can do this. If you do have any questions, give me a call. Hope things are going great, and I can't wait to see you again. Bye.